5.3 intro. So this is just the first steps of doing 5.3 problems. We know that if we want to solve an equation, we need to isolate x. Now we're going to be solving trig equations. Our first step is to isolate the trig. Eventually we will isolate the x, but our first step is to isolate the trig, and that will be our focus today. So before we jump into trig, let's recall just solving for x. Say we have this problem, 4x squared plus 4 equals 5. To isolate x, first we need to get the x term by itself. So I'm going to move the plus 4. I'm going to subtract 4 from both sides. I get 4x squared. 5 minus 4 is 1. To get the x by itself, I want to get rid of the coefficient. I'm going to divide by 4. And then my last step is going to be to square root both sides. Again, the goal is get x by itself. X will equal plus or minus, because I choose to square root both sides, the square root of 1 over 4. The square root of 1 is 1, and the square root of 4 is 2. X is equal to plus or minus 1/2. So what we're going to be doing today is pretty much the exact same thing, but instead of having an x there, you're going to see a trig function there. So say this was 4 sine squared plus 4 equals 5. You're going to do the exact same thing. We're going to subtract the 4. We get 4 sine squared equals 1. You're going to divide by 4. Sine squared equals 1/4. You're still going to square root both sides. And you're still going to get, hold on, square root is square, sine of x. You're still going to get plus or minus 1/2. Okay, we're not done. We're not done. From here, then, we're going to figure out where the sine of x equals 1/2 and then solve for x, yada, yada. But for today, my goal is to just get the trig thing, sine by itself, cosine by itself, or tangent by itself. Example, isolate the trig function. Number 1, secant squared of theta minus 6 equals -4. So my first goal is to get the secant squared thing by itself. I'm going to add 6 to both sides. I get secant squared theta. -4 plus 6 is 2. I'm going to square root both sides so that I get the secant, if I square root both sides, I get the secant of theta is equal to plus or minus square root of 2. It's cool, just leave the square root, which is fine. I have my trig function isolated. This is an acceptable answer. However, I'm not comfortable with the with the secant graph. I know the sine and cosine and tangent graph really well. I'm going to try to get sine, cosine, or tangent by itself. So again, this is okay because I'm more comfortable with cosine. I'm going to get this to cosine. Secant is 1 over cosine. So if I multiply both sides by cosine of theta, I know this looks weird, and then I divide by this root 2, I get plus or minus 1 over root 2 cosine of theta. We'll work with this because at least then I can study a cosine graph and then figure out what my x is going to be from there. Number 2, tan of x sine of x minus 4 tan of x equals -3 tan of x. This looks kind of crazy, but I can divide everything by tan. Every term has tan. This has tan, this has tan, this has tan. So I'm going to divide everything by tan of x, tan of x, tan of x. That basically cancels out all of them. Then I'm left with just sine of x minus 4 equals -3. Yeah, definitely, that was a good choice. Then I'm trying to get sine by itself, so I'll add 4 to both sides. So I get sine of x is equal to 1. And again, that's all we're trying to do today is get sine by itself or cosine by itself. Number 3, 3 sine theta plus 2 sine squared theta equals -1. Okay. I'm trying to treat sine as an x. I'm going to add the 1 to the left so that I have everything equal to 0. Because I see that there's a squared and a not squared, so I think I'm going to be factoring. So first I'm going to write the sine squared term first, 2 sine squared, then the regular sine plus 3 sine theta. And then the -1 was on the right, and I move it over to the left, so it's a +1. And then I'm going to factor. So the only way to get 2 is 2 times 1, so I know that it's going to be 2 sine theta something something, and then sine theta something something. Looking at my last number, it's just 1. The only way to get 1 is 1 and 1. So I'm here and I'm here. My signs, I see a plus and a plus. So I'm guessing everything in here will also be a plus and a plus. Let's check. 2 sine squared, good. Plus 2 sine plus 1 sine is 3 sine, perfect. Plus 1, perfect. Okay, so I factored. What was I trying to do again? Get sine by itself. Okay, well, if 2 parentheses get multiplied and it equals 0, that means either the first one equals 0 or the second one equals 0. So then from here, I could have 2 sine theta plus 1 equals 0, or sine theta plus 1 equals 0. So either the first parentheses or the second parentheses has to equal 0. Then I solve. So for the first one, I'm going to -1 on both sides, and then I'm going to divide by 2. This leaves me with sine of theta equals -1, -1 over 2. And that's what I wanted, right? For today, I just wanted sine by itself. Over here, I'll just -1 on both sides. I'll be looking for where sine is equal to -1. Again, we're not done. From here, then, I would continue and solve for theta. But for our purposes today, we're just trying to isolate the sine or cosine functions. Okay, so this is your goal. Ultimately, what you're doing is you are treating sine of theta or cosine of theta as you would x, as you would y. So keep it together. You can't separate the sine from the theta. Just keep it together as one chunk. And just like you would solve for x, solve for sine of theta. Just try to get it by itself. All right, that's all.